Welcome back everyone. This is the first video in our new unit on electrostatics, and last unit we looked at circular motion and lots of centripetal forces, and in particular the force of gravity, which was caused by the mutual attraction of two masses. So in this unit we're going to be looking at the interaction between charges. And so we'll start with the definition of what electrostatics is. And basically, statics is at rest, and electro refers to charges. So our definition is charges at rest. But then that brings up another question, which is, what is a charge? Well, charge is a fundamental property of matter just like mass. And we usually represent charge with a Q. So here's a charge. That's how we could represent it. And in real life, they don't take up a lot of space if they're just one charge, but you could also have a distribution of charge, and we'll get to that a little bit later on. Okay, and so charges can be positive or negative, and you probably learned about this back in middle school, so this is nothing too exciting. But if you have two positive charges, they will repel, so likes repel, and the same is true of two negative charges. They will also repel each other. And if you have a positive and a negative, then they will attract. So opposites attract. Okay, and so this is pretty basic. Okay, now the unit of charge is called the coulomb, and this is one of those things where a unit was given to charge before people really knew how big a number it represented. So what I mean by that is that the basic unit of charge, or the elementary, is often written with a lowercase e, and that represents 1.609 times 10 to the negative 19th coulombs. So the coulomb is with a C, after the French scientist Charles Coulomb. So that's the unit, and we often write things in terms of this elementary charge. So in chemistry you might learn about an ion, such as, well, just the hydrogen ion. Okay, so you have basically a proton, and it had an electron, but now that electron is gone. So H plus is an ion, and that has a charge of 1e. That's the charge of it, Q. Okay, but you could have more complicated things. You could have perhaps a molecule that has a charge, let's see, what's a good one? I don't know if this is right. You chem people have to tell me. Maybe this is a phosphate ion, okay? And that is 3 units of elementary charge. And so if we wanted to calculate the amount of charge that represented, well, we would just take 3 and multiply it by 1.6 times 10 to the negative 19th coulombs. And that's going to be negative because we're talking about 3 negative charges with the 3 minus. Now H plus would be plus 1e. So we don't really put a plus or minus sign in front of the elementary charge e itself. But I hope you realize by now that this to the negative 19th means that it's really small. And so 1 coulomb is actually lots of charge. And we'll talk about this a little bit more later, but something like lightning, for example, is, well, a bolt of lightning is about 3 coulombs of charge. Okay, so we're talking about an enormous amount of charge if we're dealing with coulombs, which is a little bit different from mass. 1 kilogram is really not all that much. when we talk about planets and stars and things of that sort. Now, because of this, you'll often see charge written with prefixes. And some common prefixes that you will see is mu, and that's not the coefficient of friction. That stands for micro, or times 10 to the negative 6th. You will also see NC, which is not failing a class because you were absent too much. That's a nanocoulomb. If you're watching this and you're not an ETHS student, that joke may not make sense. But a nanocoulomb is 10 to the negative 9th coulombs. And you might even see a picocoulomb. Okay, so a pico is times 10 to the negative 12th. But these two are the most common, the micro and the nano. Okay, and the last important thing that we should talk about in this introductory video is the concept of conservation of charge. Okay, now we've talked about conservation laws before. Conservation of energy means that energy can be converted from one form to another, but not lost. And conservation of charge is basically the same thing, is that the total amount of charge, the total amount of charge in a closed system, remember what that means, that we have to define a system, is constant. Okay, so that means that charge can and does move from one place to another, but the total amount of charge contained within the system will always be a constant. And we'll talk more about charging in the next video.